So we're going to do a proof of L'Hopital's rule, the theorem, based on the 0 over 0 case. Okay, so now we're going to do the special case. I'm going to prove this for the special case that, under the assumption that f and g and f prime and g prime are all continuous. And also that they're continuous over open interval containing A. Okay, so that's the special case. So I'm going to do this. So for the special case, that f, g, f prime, and g prime are continuous over an open interval containing A. Okay? Now, in that case, right? So in this case, since f of A, right, the limit of f of x and the limit of g of x are both 0, right? So in this case, since the limit as x approaches A of f of x equals the limit as x approaches A of g of x is equal to 0, and f and g are continuous, okay? It follows that the limit as x approaches A of f of x is equal to f of A, which is equal to 0, and the limit as x approaches A of g of x is equal to g of A, which is also equal to 0. Okay, so again, we've seen that before in the previous discussion. Okay, now, so based on this, here's our conclusion. Okay, so therefore, what do we have? Well, we start with the limit as x approaches A of f of x over g of x. Okay? And what we're going to do is we're just going to subtract off f of A. Because since f of A and g of A are both 0, it doesn't affect anything. So I'm going to write this as equal to the limit as x minus A over f of A, f of x minus f of A over g of x minus g of A, right? So that's the same, right? We didn't change anything, okay? And that's because f of A and f of g are both 0. Now what I'm going to do is I'm going to divide both the top and the bottom by x minus A. So some of you might see where this is going. So this is going to be the limit as x approaches a of what? I'm going to get f of x minus f of a over x minus a. And then I'm going to get g of x minus g of a over x minus a. Okay? Now what do we do? Well, now, since these are continuous functions, I can split this up and use the quotient rule, right? So this is going to equal the quotient of the limits. So it's going to be the limit as x approaches a of this. And notice this is a difference quotient, and this is a difference quotient. So I'm just going to write it out. Okay, so there's that one. And then on the bottom, it'll be the limit as x approaches a of the bottom difference quotient, but for g. Okay, now, well, the top is just the definition of f prime of x. Right? Or excuse me, I'm sorry, f prime of a. And the bottom is just g prime of a. But since f prime and g prime are both what? Continuous, guess what? We can write these as limits. So the limit as x approaches a of f prime of x. And this is the limit on the bottom here as x approaches a of g prime of x. And then again, because they're continuous, I can write this as a single limit. So the limit as x approaches a of the ratio of f prime of x and g prime of x. And that's the conclusion we wanted. Okay. So note that L'Hopital's rule states we can calculate the limit of a quotient f over g by considering the limit of the quotient of the derivatives f prime over g prime. Okay. All right. Have a great day.